All right, welcome back to my channel. Today, I want to talk about SSH. I'll show you how we can build this extremely simple CLI in Go. It's not really a CLI, it's a script in Go that is basically going to log into a VPS, run a command on it, and then show us the result of this command on our screen. So if I run this, you'll see now that we have tried one private key and that didn't work. We tried another private key, so that's important that you can try. That's what happens when you do SSH root at, and then we connected to the VPS, the VSSH, and then we ran this command that basically print that it's running Ubuntu. Obviously, I am not on Ubuntu, I'm on a Mac, so this really ran on the VPS. Now, before I get into this, I'll just show you quick, brief explanation about SSH so we understand the code much better. So let's do that first. So what is SSH? SSH is basically a protocol. It's basically a protocol that allows two machines to communicate together. Now, in the protocol, in the standard protocol, there are 4 channels defined in the protocol. The first channel is the session channel. This is a channel that you and I are very familiar with. This is a channel that we use to basically connect to a server and then run commands on that server. In this case, we are asking for a TTY from the server. There are also other channels. One channel is called direct TCP/IP. In this channel, we are basically forwarding traffic from the client, which is our machine, to the server. So you can imagine if the server has a service running on a specific port and we are sending that traffic over there. And you can do the opposite, which is basically forward the TCP/IP. So if you have a service running locally, but you want the traffic that goes to the server to be forwarded back to your service, use the forwarded TCP/IP. And finally, there is X11, which basically the server will send you some GUIs into your client. Now, I'm running through these pretty quickly. If you want to learn more details, read the write-up or the blog post that I have on the website. I will leave that down there in the description below, so you can click there. I just don't want this video to be like 15 minutes long. So that's basically SSH protocol. This basically stands for secure shell, and these are different sessions. These are different channels that you can use in that protocol. Notice there is also OpenSSH, which probably is the version that you and I are using, which adds 2 more channels. Again, I'm not going to go into that today. The second thing I want to talk about is how does that work? So the way SSH is super secure is that that the login mechanism in it is basically called public key cryptography. In public key cryptography, we own the private key, which is basically the client, and the server will have the public key. And through some dance that we'll go through now, we can 100% confirm that basically the person who is trying to connect to that machine is the person who says who basically the person who owns the private key associated with the public key that the server have. So before you start connecting to any machine, if you go to DigitalOcean or Hitzner or whatever, you have to generate an SSH key and then give them the public key, and then the server is going to keep that public key in one file, authorized keys, and they know these are the keys that are allowed to connect with me, and then we keep the private key in our machine. So how does that work? What happens is the first step that we communicate to the server, we just say, hey, we talk to the server and we say, hey, dude, we have this key. I have the private key associated with this public key. Do you accept this public key? So we are offering a connection to the server. This is what happens when you say, I want to SSH root at blah, 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 blah. So my client is saying to the server, hey, dude, I have the private key associated with this public key. Do you have that public key? And then basically the server will say, yep, I got you. I have this public key. I like this public key, but you need to prove to me that you have the private key. What happens is basically the server will send us a random string. In this case, I'm calling it banana, and they will chuck that string back to us. And what the client will do, again, this is our machine. We're going to sign that private key we're going to sign this random string with the private key. And once we sign it, we send it back to the server. The server is going to confirm that it is banana. Not exactly, there's a little bit more details here, but basically the server is going to confirm that this string was signed by the private key associated with the public key that the server owns. In this case, what this mathematical operation proves is that you said, basically the client, you said you have the private key, and now you've proven to me that you do have the private key. Now I can give you access to whatever you ask for. Okay, cool. So I hope this makes sense. I'm not going to spend so much time on this. If you want to learn more about this, please go through the blog post that I have linked below. I'll go in more details there. Let's now jump into the code, and then I will show you how you can write a very simple Go application, which we can do this basically, and it will all happen from Go. Now, the first thing you need to do is basically install the package for SSH that comes with Go. It's not installed. You need to install it that way. So go get golang xscript to SSH. That's the first thing. I already installed that, so nothing will happen. Fantastic. Now, I have added already some kind of like boilerplate here, so you don't have to watch me type this stuff. We're gonna try two keys just to show you that the way it works is I'm going to try one key, that key will not work, and then this second key is the key that will work. This is the guy that I just deleted. This is the key that will work, and then you will see when it works. I have also defined here the server address. I'm going to delete this VPS, by the way, by the time you watch this video, so please don't muck around. And then we have two variables here that will make things easier later. And the idea is, what we are going to do is, we basically are going to loop over this list of private keys that we have, and for each private key, we are going to try to connect to the server. If it works, then we are in. If it doesn't work, then we have to try the next one. Cool. So let's do that. Again, the code is really simple. I'm going to be ignoring a lot of errors here. Again, if you want to see the real actual code, and if you want to get access to the code as well, please check the blog post below. So what we're going to do first of all is we're going to read the key itself. So key bytes here, I'm going to read it in bytes, obviously. And then again, I'm ignoring the errors here. What that will do is os.read file here. So I'm going to read that key. Okay, cool. So we don't have a key first. We need to loop over it. So let's just say for, I'm going to ignore the index, and I'll get access to the key, which will come back from the keyword range, SSH keys. That's right. So I'm looping over those keys. This bad boy line will come over here. I'm going to save this. Okay, it won't work. Let's try. So let's go here. And then what I will do now is I will basically replace this to be key. Cool. So what I'm doing now is I'm looping over the keys, and I'm trying to read the first key in bytes. Now that I got that key in bytes, what I need to do is basically turn that key, that private key, into something that SSH package can understand. Remember what I said earlier? The way we communicate, the way the private key is being used in this dance is that the private key is used as a signature, as a signer. We use it to sign the random string that we get from the server. That's what I'm going to do here. So we need to parse it to get that signer. So I'm going to get from this this is Singer anyway. What I'm going to get from this method is basically the signer. Again, I'm ignoring errors. Please don't hate me. This is just trying to make the code as easier to read as possible. So I'm going to get the signer here. And the way I'm going to get this from the SSH package, I can use this parse private key method. So I'm going to parse the keys of the bytes of the private key. In this case, it's called key bytes, basically the bytes that I've written. Fantastic. And then once I get that signer, I'm going to use it to form my client. Then I'm going to use that client to communicate with the server. So let's do that. So let's just do SSH client, SSH config, sorry. I need to make the config first. I'm going to do SSH conf. Yep, SSH conf. That would be equal to a pointer to SSH.client config. That's right. And then we need to specify some configuration for connecting to the server. The first config obviously is going to be the user. This usually is root. Again, that will be changed, but I'm trying to simulate what you do when you do SSH root add blah, 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 blah. So that's one. And then the other thing is basically the auth methods. And in this case, we need to pass SSH the auth method, basically a slice of SSH auth methods. And then in this case, we just say, get me basically the signing associated with the public keys of the signer that we just got here. So basically, that's how I'm using the signer here, by basically passing it into this method with the public keys. And then this is important. I'm going to skip it now. But basically, the host key callback. Now, I'm not going to go into details what this is, just because the video will become too long. But basically, I'm going to give you like a glimpse of it. What happens is when the server is telling us, I have this specific public key. Now, we need to confirm that the server is who it says it is. So what happens is in our local, we say, okay, we know that this server has this public key, and we know that this server has this public key, and we can trust that the first time we communicated with the server, it was actually the server that we are talking to, and that server has this signature of the key, and we are happy with it. Now, this is why the first time you connect to a server via SSH, you will see this part that says, hey, I got the signature of the public key. Do you want to accept this fingerprint or not? And the reason why we click yes or no is basically we are establishing that we trust that the server that says, I have this public key is actually the server that we want to talk to. Because the concern here is that we can have a man-in-the-middle attack in which another server can have a copy of that public key and says, hey, I am the server that you think I am. And then that man in the middle will basically hijack our connection to the main server, and we'll be talking to a completely different server. So this is basically a way for us to confirm. So you can do different things to confirm that this server actually is a server that you want. In this case, I'm simply just going to ignore it, insecure, ignore host key. Again, do not do this in production. Obviously, in Sidekick, we don't do this. We confirm it. We show it to the user. Sidekick is the CLI that I use to deploy everything. You can check that out again in the description as well. But basically, do not do this in prod, right? So don't do this in prod, but in this case, I'm just going to do it that way. And then finally, I'm going to add some timeout here. I'm going to time out of 4 seconds, for example. So it's 4 time dot seconds. Cool. So I'm going to give it like a timeout of 4 seconds. So what does this mean is we are trying to connect with the user root. And then we are trying to connect with this specific signer that comes from one of the keys. And then we are going to ignore this confirmation about this dance that I just told you for the sake of simplification. We're going to wait 4 seconds before we just time out and we see that, okay, this key just doesn't work, and we move on. So now I have the SSH config. I'm going to use that SSH config to dial to my server. So this will give me the SSH client. So I'm going to say this is SSH client, and I'm going to have this dial error as well. Dial error. That's not cool. Dial error. D will come from ssh.dial. So when I do this, I'm going to connect through a specific network. Obviously, that network here is TCP. SSH happens over TCP. And this is the address here. I already have the server address over there. Notice also that the server address here has the 22, which is the port. This is the standard port for SSH. You can change that if you want. It's not the best idea, but it's up to you. Basically, this is the server address, :22, which is basically the port that you're trying to connect at. And then finally, this is the config. This is the config that we have this is the config that we have just established just now. And then this is going to give us the SSH client and that error. The reason why I care a lot about this dial error, because it has to do with our loop here, it's going to be very essential to understand what we do next. So what I will do here is basically I will say, look, if you have a dial error, so if the dial error does not equal nil, that means basically this specific key failed. So I'm just going to say key login failed. So one of the key failed with a D. Okay, wow, if I can type today, cool. That's it. That means I have an error here with the dial. And then if I don't have an error, if I don't have a dial error, that means I have already established connection. So I'm going to do from to the print line. I'm just going to call this I'm in. And that means that I have actually established this connection. Now, just to make sure that things don't break, by this point in the program, I need to check that my SSH client is not nil, because if my SSH client is nil, that means all the keys that I've tried did not work. So basically, I'm gonna go log.fatal, and then I'll just say all keys didn't work, and then that will panic and it will exit, and that's what it is really. Now, at this point in the program, at this line 48, we know that we have an SSH client, and we know that we can connect to basically that server. So what I need to do now is basically establish a session. Remember the channels? I'm going to establish a session. Before I forget, I'm going to defer SSH client to close that client basically. So make sure that you don't forget to do that. Fantastic. Now, what I will do is I'm going to get a session and an error also that I don't care about at this point. And then that will be SSH client.new session. So I'm basically asking for a session. So I know that I have established this connection. Now give me a session that I can talk to. And again, I'm going to defer close that session. Again, you can see that I'm avoiding all not handling all the errors. But again, if I do handle the errors, this video is going to be a lot longer. And then now what I will do is basically I'm going to say, hey, in that session, just give me the combined output of a command that I'm going to run. And this command is going to be basically cat, show me one second, show me the contents of OTC OS release. And then what I will get from here, I'm going to get an output, and then I'm going to get SSH error in this case, right? Basically an error of writing this specific command. I'm going to say if SSH error does not equal nil, then I'm going to panic, log.panic. Log.fatal basically in this case, and then I'm going to say failed to run command. And then basically what I'm going to do here is fumpt print line of, I need to cast this into a string because it comes back as bytes, and that's the output that I get back from the server. Now let's run this real quick. So go run main.go. And you'll see here first, this first key is basically failed, and then I am in, and then I have all keys did not work. What have I done? My bad here. This is equals nil. Apologies for that. Let's go again. So I will try one key, and that's the first key that failed, like I said, and the second key worked, and this is basically the output of that command. And obviously what happened is we have ran this command right here. This basic command right here has basically ran on the server, and what I'm seeing here is basically the output of that command. Now, this is literally just scratching the surface. There's so many more things that you can do with SSH. For example, when you do this combined output, when you do this combined output, you are getting basically the output that basically will give you the standard output and also the error output. So that's the combined output right there. So you can see here, this combined output runs the command and then returns this combined standard output and standard error. Yeah, this is just easy to handle and so on, but this guy, the output will give you basically the standard output only. Again, this is not very good. The way you should actually try to do this is basically you want to hook into two pipes, one pipe for the standard output of the server, and the other pipe is for standard error of the server. And then now you have access to two outputs that come from the server, and you have this real-time connection with the server. Then you can run commands, you can basically handle the errors in whatever way you want, and basically handle the output in whatever way you want. So this is a very simplified way to do this. There's also different ways where you can basically establish this connection to different pipes on the server and then make a command, but don't run it yet, and then run the command and wait for it. Or you can run the command and block your program until this command finishes. So yeah, the SSH method, SSH package in Go is very, very like flexible and allows you to do a lot of things. I'm not going to go into more details. If you would like, you can check out Sidekick on GitHub, where you can just see a lot more details, a lot more examples of how I use SSH package to do this. That's the end for today's video. Again, I'm trying to make it short. It's already around 19 minutes or 18 minutes. I hope you liked it, and let me know what you think in the comments below. See you later.